so you're sitting in Senner's math class again because you have to, and you're in section 2.3 and you can't remember what the title is, but you do know there's some kind of function. So you write out 3x cubed plus 8x squared plus 5x minus 7. And you're wondering, does this thing divide by x plus 2? Let's find out. Maybe I can use long division from long ago. So I set up the long division problem with the good old long division box and start dividing. Let's see, x goes into 3x cubed, 3x squared times, multiply, subtract, don't forget how to subtract. 8 minus 6 is 2, x squared, bring down the rest of the stuff. X goes into 2x squared, 2x times, multiply those, bring them down, subtract. 5 minus 4 is x, bring down the negative 7, x goes into x one time, and 1 times 2 is 2, subtract, you get negative 9. So I'm going to write my answer as 3x squared plus 2x plus 1 minus 9 over x plus 2, because I divided by x plus 2. Now, if x plus 2 was equal to 0, then x would be negative 2. I can make a coordinate out of that. That would be negative 2 and negative 9. How cool. All right, let's take a look at another function. F of x equals 2x to the 4th power plus 7x cubed minus 4x squared minus 27x minus 18. Let's do something called synthetic division. Synthetic division is like fake division because you're really not dividing, you're multiplying. 2 times 2 is 4, 2 times 11 is 22, and so on. When you end up with this one, you get a 0 on the end. That means it divided evenly. So it divided evenly. Let's try again with the remainder, or the quotient, sorry. This time we divide by negative 3, and we get 2, 5, and 3. This is really meaning 2x squared plus 5x plus 3, and we factor that. If we can't factor it, then we use the quadratic formula. But we can. So 2x plus 3 times x plus 1. Our function now is f of x equals 2x plus 3 plus, or times x plus 1, and then the other one would be x minus 2 and x plus 3, of course. X minus 2 and x plus 3. This means our zeros are negative 3 halves, negative 1, 2, and negative 3. There was a guy named Descartes that had some kind of rule of signs. If you look at all of the pluses and negatives, positive and negatives of the function, you might be able to determine if the zeros are positive or negative, or how many you have of each. We have plus, plus, minus, minus, minus. There's one time where it changes, which means there's one positive 0, and it's 2. What if we plug in, say, negative x for x? So negative x in every location, 2 negative x to the 4th, plus 7 negative x cubed, and so on. What does that do for signs? The first one would be, say, plus, then minus, then minus, then plus, then minus. How many times does the sign change now? Once, twice, 3 times. There's 3 possible negative zeros. And we had 3 negative zeros. All right, well, how did we know what to divide by in the first place? Well, there's a trick for that. Label the last number p and the first number q. Set up p over q and divide. P is the factors of the last number, 1, 2, 3, 6, 9, and 18. And q is the factors of the first number, 1 and 2. 2 is one of them, and negative 3 is one of them. That's how we knew what to divide by. And everybody's happy.